absolute value equations and inequalities. First, let's start with absolute value equations. This is an example of an absolute value equation. Now, is -3 a solution to that absolute value equation? Remember that if we plug that number in for x and we have a true statement after we simplify, then it is a solution. So let's go ahead and check. I'll put -3 in place of x in the original equation, and the absolute value of -3 is 3, which does equal the right side 3. So yes, -3 is a solution to the absolute value of x equals 3. Now, with solving absolute value equations, first recall that an absolute value is defined as a number's distance from 0. The absolute value of x equals 5 can be read x's distance from 0 is 5. Now picture the number line. Where on the number line are there numbers that are 5 units away from 0? Here at 5 and at -5. Both numbers are 5 units away from 0. So the solution set to this absolute value equation would be -5 and 5. For absolute value equations, if k is greater than 0, then the absolute value of ax plus b equals k is equivalent to ax plus b equals k, or ax plus b equals -k. In other words, we're taking the absolute value of some quantity, and it is k units away from 0. That must mean that the value inside there either equals a positive k, so that it's k units to the right of 0, or that quantity inside there must equal a negative k, so that it's k units to the left of 0. Either way, the distance that this expression is away from 0 is k. Determine whether the given values of x are solutions to the absolute value equation. Again, we'll plug these numbers in. Absolute value of 2 times -3 minus 5 equals 1. That gives me a -6 minus 5 in absolutes equals 1. The absolute value of -11 equals 1. So 11 equals 1, which is not true. So I know that x cannot equal -3. Let's try x equals 3. Absolute value of 2 times 3 minus 5 equals 1. So the absolute value of 6 minus 5 equals 1. Absolute value of 1 equals 1. So 1 equals 1 is a true statement. That must mean that x does equal 3. Solve the absolute value equation. X's distance from 0 is 3. So I know that x must equal 3 or x equals -3, because both of those numbers are 3 units away from 0. Absolute value of 1/2 x minus 1 is 5. So I know if the absolute value of this, the distance that this is away from 0, is 5, that must mean that that expression has a value of 5, or maybe it has a value of -5. That would make it 5 units away from 0 on either side of 0. Now I have 2 equations to solve. So over here, of course, I'll add 1. Then I multiply both sides by 2. I get x equals 12. On this side, I add 1 again. And I multiply both sides by 2. So I have two solutions, 12 and -8. You could place these into the original problem and both answers would cause the statement to be true. If x equals 12, half of 12 is 6, minus 1 is 5, and the absolute value of 5 is 5. For -8, half of -8 is -4, minus 1 is -5, and the absolute value of -5 is 5. 2/3 z minus 1 in absolutes minus 3 equals 8. Now, this is a little different than the last couple of problems. I first need to isolate my absolute value. If you look at this property of absolute value equations, it says that the absolute value all by itself on one side equals to k translates to this or statement. So we first must get our absolute value all by itself. So to do that, I'm going to add 3 to both sides. That gives me a 2/3 z minus 1 equals 11. Now I know that if the absolute value of 2/3 z minus 1 is 11, then 2/3 z minus 1 must equal 11, or it must equal -11. Now I'm going to solve both of these equations. 2/3 z equals 12. When I multiply both sides by 3/2, I get z on the left, and on the right 2 cancels 12 6 times 3 is 18. Or over here, 2/3 z equals -10. When I multiply by 3/2, I get z on the left, and on the right I get a negative. 2 goes into 10 5 times 3 is 15. So my two solutions are 18 and -15. Now let's move on to absolute value inequalities. Determine whether the given values of x are solutions to the absolute value inequality. Here the inequality is absolute value of 12x plus 3 is greater than or equal to 3. I have these two possible solutions that I need to check. So let's plug in the -1/4 first. Absolute value of 12 times -1/4 plus 3 is greater than or equal to 3. Absolute value of -3 plus 3 is greater than or equal to 3. -3 plus 3 is 0, so I have the absolute value of 0 greater than or equal to 3. Now 0 is greater than or equal to 3 is not true. So I know that x equals -1/4 is not a viable solution. Let's try x equals 2. Absolute value of 12 times 2 plus 3 is greater than or equal to 3. Absolute value of 24 plus 3 is greater than or equal to 3. So 27 in absolutes is greater than or equal to 3, which gives me 27 is greater than or equal to 3. That's a true statement, so x equals 2 is a possible solution. With solving absolute value inequalities, we'll have two different kinds. First off, we'll have absolute value of x less than some number. We'll say 5 here for this example. And this can be read, x's distance from 0 is less than 5. So think on the number line, what numbers on the number line would be less than 5 away from 0? These numbers would certainly be less than 5 away from 0. Also, we have these numbers. These numbers are also less than 5 units away from 0 on the number line. So I end up with this interval. Let's go ahead and put our parentheses on the end since it's a strict less than. So x will be between -5 and 5. Algebraically, -5 is less than x is less than 5. When the inequality sign points in, like this, towards the absolute value, we can think of it as an any, just a fun way to remember what's going to happen with this inequality. We'll have a single inside interval as our answer, -5 to 5 in this case. Now we have another kind of absolute value inequality. Absolute value of x greater than 5 can be read x's distance from 0 is more than 5. So if you think about on the number line, what numbers are more than 5 away from 0? That would be numbers out here. It would also include numbers this way. These numbers still have a distance that are more than 5 away from 0. And since we have a strict greater than, we'll put rounded parentheses. So x will be less than -5 or greater than +5 for it to be more than 5 away from 0. Algebraically, this is x is less than -5 or x is greater than 5. When the inequality sign points out, away from the absolute value, we can think of it as an outie. Again, just another fun way to help remember what's going to happen with an absolute value inequality. We'll have two outside intervals as our answer. We'll join these with a union, -infinity to -5, union 5 to infinity in this case. Now similar statements can be made with the symbols less than equal to or greater than equal to. The only thing that would change is that our parentheses would turn into square brackets. Let's solve this absolute value inequality, and we'll write our answer in interval notation. Here I'll have an any. It's pointing in. So for x to be less than 3 away, it must be between 3 and -3. On the number line, all we need to graph is -3 to 3, shade in between, and here we'll put square brackets since we have the equal to part in our inequality. Our answer in interval notation then is -3, 3, square brackets on both ends. Let's solve this absolute value inequality. Here x is greater than 4. So we know that this is going to be an outie. We'll have two statements joined with an or. So for the distance of k to be more than 4, we have to say that k is greater than 4 or k is less than -4. In other words, k is to the right of 4 or k is to the left of -4 in order for us to be more than 4 units away from 0. Again, we'll graph our -4 and 4, and k is greater than 4 or k is less than -4. And we put parentheses on those. In interval notation, we'll have -infinity to -4, union 4 to infinity. That union symbol just symbolizes the word or. In solving this inequality, let's see, we have a -4x plus 4 must be less than 16 and greater than -16 at the same time. Remember, it's pointing in, so we'll have a single one inside interval. Now I need to solve this three-part inequality. I'm going to subtract 4 from all three parts. I get a -20 less than -4x less than 12. Now when I divide by negative 4, I get a 5 greater than x greater than negative 3. And I put this on the number line. I want to put my negative 3 here and my 5 here. And remember, this is read backwards. If you want, you can rearrange that. Just flip the whole thing back around. And x is between negative 3 and 5. In other words, x is less than 5 at the same time that it's greater than negative 3, and this interval satisfies. Now I have the interval notation of negative 3 to 5. In solving this absolute value inequality, I first need to isolate the absolute value. So I need to get rid of this 2. We'll divide both sides by 2 just so that we can isolate that absolute value. Now I have an outie, so I'm going to have two statements joined with an or. For this expression to be more than 4 away from 0, I have to have x plus 5 is greater than equal to 4, or x plus 5 is less than equal to negative 4. So things that are to the right of 4 or to the left of negative 4 are going to be more than 4 away for their distance. Now I saw these individual inequalities. X is greater than equal to negative 1, or x is less than equal to negative 9. I get my graph. I know that x is greater than negative 1, less than negative 9, and I have the equal to, so I'll have square brackets. And the solution then is negative infinity to negative 9 union negative 1 to infinity. Solving this inequality, I have x plus 6 in the absolutes greater than equal to negative 5. So let's go ahead and just follow what we've been doing before. I first know that I'm going to have an or. What we've been doing is flipping this inequality and changing the sign of that number. So if I subtract 6 from both sides, I'll have x greater than equal to negative 11. Subtract 6 here, I have x is less than equal to negative 1. Now on the number line, plot those points, and I have, let's see, x is greater than equal to negative 11, so that would be this, or x is less than equal to negative 1, that would be this. So we end up with everything being shaded on that number line, or in other words, our solution is negative infinity to infinity in interval notation. Now let's look at the original inequality and see why this might be true. The absolute value of something, we don't care about what kind of statement is in there, the absolute value of any number is always greater than equal to negative 5. So that's the reason we end up with negative infinity to infinity. We can pick any number up from the number line, put it into this inequality, and it will make the statement true. Here I have another outie, so I'm going to have an or statement. 2 minus t over 3 greater than equal to 5, or 2 minus t over 3 is less than equal to negative 5. So for our distance to be more than 5 away, we need the expression to be bigger than 5, or the expression to be less than negative 5. Multiplying both sides by 3, subtracting 2, and dividing by negative 1, flipping my inequality, I get t less than equal to negative 13. We do the same thing over here, multiply both sides by 3, subtract 2, and divide both sides by -1. So I get t greater than equal to 17. Again, when I'm graphing this, then I have t is less than equal to -13, or t is greater than 17. That gives me interval notation of -infinity to -13 union 17 to infinity. That does it for this lesson. Go ahead and try your homework and be sure to let me know if you have any questions.